Good morning. Today we're going to be continuing on using sprite shapes, and I'm going to be doing a transition that's going to look like this. So we get a solid screen which these spiky things kind of extrude over, and these are all PNGs at 1920 by 1080. I don't want to waste up all my memory using a whole bunch of PNGs, so I'm just going to use a sprite shape and use math to be able to calculate that. I will be using a plugin called DoTween, which will be calculating the movement of all these pieces. For one of the things we want to look at is there's some spikes to this, and we've got, if I look at a sprite shape, the bottom left corner is normally the first index for all the points around it. So if you've got a square, it will be 0, 1, 2, and 3. So 0 is bottom left, then it's top left, top right, bottom right, and then they close the shape. We're going to have a whole bunch of spikes on this side, so I'm going to need multiple points. So the bottom spike here that you barely see is going to be our 0 point. And how many spikes are there? There's 0, 1, 2, 3, 4, 5, 6, 7, and the top one is 8. Meaning we've got 16 points in total because we're going to need points in between to make these curves. Let's get started with creating our sprite shape. And just so that I can see the difference between the shape and the border of the camera, I'm just going to make a quick change here and give it a color. There we go. When we also look at the sprite shape, we can see that we're not getting exact to this line. We've got this border that's going on here. If I try to remove the height on that, then the most I can go down to is 0.1. There's always still going to be a little distance there. And also, if I go and set these to corners, we get all this weird artifacting going on. So set that down to 0. 0, make you a corner as well. And 0, make you a corner as well. Okay. Now, that's going to be a problem with this, because there you can see that corner happening, this distance happening. And that's because they want to use a graphic sprite here to be our line. And that can only be so small. I've created a profile that basically does not have a sprite for the line. So that removes the line altogether. I've also got use sprite borders turned off. Okay, that gives us a nice shape without the line. Now, where do we put these points? So I want it to be to the top and bottom, left and right of the camera, so it's snug to the camera. On the right hand side, I do want to be able to have some room to play with. So I'm going to move that over. And on the left hand side, we're going to start on the side and move the points over to the right. Here's the problem with this though. I'm using this as a shape that's in my world and not a canvas. So the canvas has an option that allows me to rescale my canvas depending on the screen size and the screen dimensions. For that, why is that important? Because right now I've got this set up as my Galaxy tablet, and that is 1920 by 1200. It's a different aspect ratio. My cell phone is 2340 by 1080, which is a 19 by 9 aspect ratio. So if I look here, that's a lot wider than a normal screen. If I go to the normal one, which is 1920 by 1080, that's this one. So basically, how do we accommodate for that? Well, the whole thing is actually going to be controlled by math anyhow, so we're going to use math to be able to calculate that. right now it doesn't matter on the math of this. Sorry, on positioning this stuff. We're going to have the actual program take care of that. What we do need to do is make sure we have all the points on the right hand side. Like I said, this point is 1. This is, sorry, 0, 1, 2, 3. It goes clockwise around. Over here in our sprite shape, there is no possible way to see the points, but if I go into debug mode, then I have access to them. There they are. So I've got my 4 points, 0, 1, 2, and 3. And I'm going to add 8 more points, and then I'm going to subdivide those 8 points. So right now it's just as simple as just going 0, 1, 2, 3, come on, 3, 4, 5, 6, 7, and that's 8. And in between each of these is 1, 2, 3, 4, 5, 6, 7, and 8. And each of these is going to be set as because right now I have them set as a corner, and I want each of those to be, so if I go back here, normal. Oh, I gotta select them again. And I'm gonna make those continuous. So now they're curves. Their handles are unfortunately at 0, 0 around the point. So once again, we're gonna be using programming to do that. Right now, I just need to clean up what I've created here, and I'm just gonna pause while I clean that up. Okay, so I've done the math that needs to be done, and we're going to go ahead and start looking at the programming for this. I've got a script ready done, so let's go to my scripts and green white. Okay, so what do we need for this? The first thing we're going to need is I'm going to set up what the camera and everything. So I need to get my camera to find out what the actual size on the screen is going to be. Let's just put in some notes at first for my own sake. So those points 0 and 16 are the ones on the left side, and we've got the top and bottom. And then we've got points 17 is the top right, and 18 is the top, sorry, bottom right, top. Okay, let's store a camera first. We're just gonna get the main camera. Then I need to find out the orthographic size of the camera. Next, I want to know the aspect ratio. That will give me my X dimensions, because the orthographic size is actually your Y dimension. Okay, now figuring out the maximum and minimum is fairly easy. They're all gonna be floats, and this is gonna be cam Y max. And that's all you need to do to find out. So the orthographic size is actually half of the height of the camera. And I'm going to call this cam Y min. And basically it's just the opposite. So I can actually take cam Y max. And so if this is going up, then this is just negative of going down. Oh, That's important that we have to make sure that our sprite shape here is centered on 0, 0 position. I could go in and do a little bit more math to do an offset, but for now, I'm just going to go with having the math as centered. Next is our float cam x max. So this is our right side is going to be the cam ortho size multiplied by the cam aspect. And we can just do the same thing we did before. And I'm going to take my cam x max and just invert it. Let's just tidy things up a little bit. And we're good. Okay, so first 2 points that we're going to change is the top right and bottom right. Those are easy ones. The way that we're going to do this is I need to be able to grab that sprite shape. So don't go for sprite shape. What we're looking for is sprite shape controller. And I'm just going to call it green white. And I'm just going to get component and sprite shape controller. Okay, I want to do my green white dot spline dot set position, and I'm going for the number 17 top right, and it's going to be a new vector 2. I want cam x and y, so the max, and cam y max. But I do want to offset, like I said, I want some distance between the edge of the camera and that. I'm going to put this here. Just so we don't use magic numbers, I'm going to put that there, plus that. All right, I can take that, and this will be 18, and we're going to be looking at min. There, that side is done. And y is cam, y min. Thank you. For the rest of them, we're going to have to do a bunch of calculations, and I don't want to have to do it all as 0 and then 1, 2, 3, 16. I'm just going to do a loop. So for I that, and our number is 17, and I don't want to have to do this calculation over and over again, but I need to know the height of the entire thing. So I'm just going to store that as float cam height. Let's call this cam y max minus cam y min. Okay, that's the height of my camera. So if max is 3 and min is -3, 3 minus -3 is going to be 6 for a cam height of 6. Now, what do we need? I'm going to calculate my y position. And the y position is going to be I'm going to start at the min, and for each iteration we're going to use I multiplied by our cam height, and that's divided by 16. Let's do some extra brackets in here to make sure this works okay. Okay, that's the division between each of my points going up. So I'm going to do the same thing I did before. Set position. And the position of I. So we start at 0 and we go all the way up to 16. So min at 0 is going to be our whatever the minimum was, negative 1.3 or something, plus I. So on the first one, we just want it to be at the minimum. But if I is 0, anything multiplied by 0 is 0. So that remains that. Once this becomes 1, then we get the division, and then 2, and so on. So the math is going to make sense moving up. And I want this will be the cam x min and the y position. All right, that takes care of each of our points. I'm missing a bracket. There we go. Oh, I've had some comments asking about my brackets and their coloring. This is an extension called Rainbow Brackets. It's pretty useful because you can see the opening and closing of things much easier with the coloring. Not that good for colorblind people, but for people who can see colors in full spectrum, then it's a big help. All right, I've set this up. Now I need to set up the in-between ones. Okay, going into debug mode, let's look at some in-between. So I've got this guy here and this guy here, and they are 0, 1, 2, and 3. So 1 and 3. So let's look at 1 and 3. Currently they're set to linear. I'm going to want to set them to continuous, and I also need to set their tangent. So if I set that to continuous, nothing I do is going to make any difference if that is turned on. Okay, right. So if I set number 1, I'm just going to move you over so you can see it. It's not going to matter because the program is going to set its position. And I'm going to set that to continuous. And we can see the left and the right tangent are set to 0 and 0, so it's all centered. We need to set our y's. We'll leave the x's as 0. Now, how do we know left from right? We're going clockwise. So if this is our first point and we move to this point is the left, this point is the right. So any tangent that comes down here is going to be our left tangent, and the tangent going up is our right tangent. So if I take my left tangent down, we can see, and take the right tangent up. Okay, so this distance here, how much is it? Well, I know that the distance between there and there is going to be whatever our calculation is. I've done some little calculating here when I was doing my math. I should not be going over that. So this 1.8 means that my right tangent is going beyond this area here. So I want this to be my go-to. That is actually the distance between points. So the same calculation we used as the cam height divided by 16 is the same calculation we'll use. Actually, you know what? I hate doing divisions over and over. Divisions are never good calculations to do. Let's put this as and be done with it. Oops. That way I don't have to do that over and over again. Okay. Now we're going to have to go into our left and right tangent and set up their positions and their mode. This is going to get a little trickier because this is 0 and this is 1, this is 2 and 3. So therefore, this part here is every odd number. So we're going to have to do a calculation on finding the odd numbers. Okay, so we're going to be using to find out if I is going to be even or odd, and I want to do I don't do this that often. Modulo 2 is equal to 0. So what this is saying is if I divide I by 2, is the answer 0? If it is 0, then it's an even number. 2 divided by 0 is, 2 divided by 2 leaves a remainder of 0. 1 divided by 2 leaves a remainder of 1. So it can't be divided by 2. 3 divided by 2 leaves a remainder of 1. So if our answer is going to be 1, then we've got an odd number. Or I can just say not 0. And see, I was going to go with just equals 1 because that would be a quicker calculation, but we're only doing 16 things. So if it is, then I want to do that green white dot spline dot left set spline dot set left tangent, and what do we do? Left tangent of I, and this tangent is going to be new vector 2 0 comma height division. Okay, I believe before we do that, I have to set it. So let me do this and spline dot set dot mode set tangent mode. How is this done? Index I comma mode dot comma shape tangent mode continuous. There we go. And so I've got the left tangent and the right tangent. Oh, the left tangent was, is it the negative? Let's go back to here. Right, left tangent is a negative. Oops. Left tangent. So that's minus. Save, and we should have something that is going to set all of them up. I want to do something where I just want to be able to visualize it. So I'm going to take this of my position, and for all the odd ones, I just want to move it over just a little bit. I'm going to nudge it, and I'm going to add, let's add that offset that I did before. I just want to see if it's doing everything okay. Okay, let's play this and see what happens. And voila, we've got our curves. So I want these to move across the screen now, and from the start position to the end position. So let's just remove that. And how do I want to go about doing this? I'm going to be using, okay, if I'm doing the 4 in here, this sets everything up. Then I should be able to just go and say that green white dot spline. I want the odd ones to do it, so this is going to be in here. Dot spline. What if I do because to do a do tween, I need something to latch onto. If I did do, oh, first I have to go to up here and using gd dot tweening. No, I do it up here. So dg dot tweening. Yeah, there's no do tween for setting these things. What I can do is I'm gonna have to have a controller. Okay, so I need some sort of control points that I can animate, and then um, each of these points is going to latch onto it. And the latching on, let's say it's going to happen in update. So I need to create those points. And really and truly, I don't care about the Y. It's because those points aren't going to be moving up and down. I just care about the X. Let's go and say for I, and I'm going to do, once again, 17. I need 17 points. I don't need 17 points. I need only on the odds. So only on the odds am I going to create a point. And let's put them in a list. List of transforms. Transforms, game objects. Okay, and control points, control. I'm going to create all of them. So control points dot add new game object. I think the first thing is a string, which is its name. Yep. And I'm just going to call it oh, wait, rather than do that there, rather than doing two loops, why not just do one loop? And all right, the game object is control point I. That's going to need a position and everything, which is this position, and that would be parameters. I don't usually do new game objects and do a lot of fancy stuff to it, so I'm just going to say new game object, and then I'm just going to access it. So control points I dot transform dot position equals this. Actually, I can just do this. Let's say get position I. That way I'm not making two new vector 2's. It already exists. Actually, one is more memory intensive, one's more processor intensive. I don't know which is going to be worse, but we're only doing 16 things. It doesn't matter. This is not a huge AAA game. Alright, I've got a control point. I've set it up. And now I can move that control point by doing control points I dot transform dot do move x, and I want to move it to the other side of the screen, which is going to be our cam x max, comma, and the speed is, let's just say 2 seconds. All right, but I need to go through all of those points for I 16. Okay, that's good. And I now need to link the position of I. Oh, green white needs to be global. All right, and now, oh, those need to be global as well. All right, now, this is going to be, I'm getting the position. I don't need that. I'm getting the position from the control points. Control. That list also needs to be There we go. Control points I dot transform dot position. Okay. Now this is where things will get tricky, because if I was doing this as a with the curtain with the white moved somewhere else, then the problem is that our positions of our points are actually local positions. So this is a position of the point in the world. I could have made that so that it's a child of, when I add it, I add it as a child of the wipe, and therefore I could use its local position to the actual wipe, to the sprite shape. But like I said, I've zeroed everything out so that I don't have to do extra calculations. Now this should take care and go through all 17 of them, um, and set their points. All right, all that's left is to test it out. Okay, fingers crossed. And it worked. The other points I'm going to animate as well. I also want to kind of randomize it so that yeah, if you see it, it's all perfectly in line, whereas this one, they're not lined up. So the tangents, I could use a max and min on the tangents to make these different, as well as the speed that they move across the screen. So let us just take a quick look at how I would do that. We've got our height division. This could actually be a random dot range between 0, no, how would I do this? The maximum is height division, but let's do height division multiplied by 0.5. So it's going to be half of it are the full amount. Oh, random move out range, and I am missing a bracket. We start with orange bracket. Let's see, I don't want that. Okay, that should work. So I'm just going to grab all of that and, sorry, grab all of that, replace that. Actually, you know what? It's the same on both sides, so I don't want that. I want a float and then use this float. That way it's equal top and bottom. Okay, we've got that. Now I want a random speed, so let's do random dot range, and let's do 1 and 2. Oh, those should be floats. 1F, 2F. And let's give it a try and see what we have. Okay, it looked okay. Let's want to check something here. High quality, not high quality. Okay. Um, could it have been better? Let's pause it and see. Okay, yes, I'm seeing variations in those curves. Yeah, okay, that looks good. All right, I can go with that. Um, but some of that randomness, I need to hold on to it because no, um, because we've got the two layers that we're going to be doing for this. But I'm not going to go that far in this. I just want to get that first layer done, and it looks kind of good. Do we have our 1, 2, 3, 4, 5, 6, 7, 8? Oh, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8. We do have our 8 spikes. Everything looks good. And these now I would have to animate, and there's going to have to be a delay. Okay, so very quickly, I'm just going to go and swap my start to be an I enumerator. And we're going to do our yield return. Wait for seconds, and should be enough. And then we're going to go through this stuff again, but we are going to be looking at just the control points that are equal to 0. Sorry, yep. And this time do move. How do I yeah, I think that should be okay. All right, and since the update is linking each of those points, each of those 16 points to the control points, both the curve ones and the spike ones will all be updated. Perfect. Albeit the I don't like the ease in, ease out, so do move dot set ease to ease dot I hate when this happens. I can't see. In ease dot in out linear. Okay, just do linear. Just linear. Okay. Test this out and see how it goes. Oh, that would only be one of them. I didn't set it for both. Okay, I've tweaked the numbers a little bit, and here is my final result. So when I turn it on, we get that. Oh, right. All right, so that is it. It takes a lot longer than just importing this, but I get something that is going to, um, well, I can. It's a little bit randomized, which is nice. It is controlled by math. I don't have to load a bunch of graphics and try to run 1920 by 1080 graphics at full screen inside the game. So yeah, that is animating that wipe using a sprite shape and some math. And the only plugin I used was DoTween, but you could do your own tweening kind of plugin if you want. All right, so that's it for today, and I will see you in the next one.